Yes, I know there's a new setup right here because we actually moved to a new place, and so we are trying to make as much changes as possible in a timely manner to make things as effective as possible. So, yes, and welcome here to this particular video. And in here, we got some surprising information that is coming from NASA, and indeed, it's going to be mind blowing because hey, we've been talking about Hubble Space Telescope, James Webb Telescope here for some amount of months now, and yes, they're actually having something ready to go, and this is going to be happening hopefully May 2027. That is the target where they're going to be launching a new space telescope likes that have never been done before, and definitely it's going to be mind-blowing to see how it's going to be effective and how it's going to be stacked on top of that of the abilities of James Webb Telescope and Hubble Space Telescope. And this telescope is known as Roman Space Telescope, named after Nancy Grace Roman, and this here is going to help us to change our understanding of the cosmic clock, specifically looking at how universes evolved and how possibly before leading into how the early universe works, mainly not focusing on the gases and dusts that are revealed by James Webb Telescope or based on James Webb Telescope ability to use the infrared region compared to that of Hubble Space Telescope that is mainly using the visible spectrum. But this guy right here, which is the Roman Space Telescope, is going to be using techniques that actually transforms our understanding of the primordial sea and looking mainly at charged particles rather than just looking at gases and dust. So this is going to be fantastic for we to see the capabilities of this telescope here in real time, hopefully May 2027. So what is this all about? Based on this article that was released by NASA, which says that how NASA's Roman Space Telescope will rewind the universe. And so this is how it works. Now, looking at how James Webb Telescope and Hubble Space Telescope works, they mainly produce image that is more of a pinhole view of the universe. But now the goal of this new telescope Roman is to look at it at a larger view. This means that there will be some things that pinpoint in doesn't reveal, and this involves hey, how about at a large scale of things, how can we see more of the universe rather than just a little segment that James Webb Telescope and Hubble Telescope does currently. And yes, indeed, the information of all three will not be neglected. It means that when you're combining a larger view from Roman to that of just Hubble Space Telescope, which is at the specific wavelength of choice, to more of the detail that Hubble provides, honestly, it's going to be just amazing seeing all those combination of all three together. I mean, we've seen combinations of imagery coming from, like for example, you can actually see combination of X-rays with that of James Webb Telescope, infrared region, near infrared region. But now looking at the complexity that is adding another layer to it, Roman, it's going to be mind-blowing visuals with so much more analysis and detail, and this comes into the timing of the production of such images according to this article. Now, putting the scanning technique into perspective, if you look at Hubble Space Telescope in terms of that screenshot, it will take around 85 years in order for it to map that entire region. However, guess how much it's going to take Roman to scan the entire space right there? Decades? Centuries? No, 63 days. That is mind-blowing, honestly, just to get that huge large view alongside having the speed of that survey is such a great advantage of the Roman Space Telescope ability and how much more we can spend in terms of analyzing those data of that entire thing that have never been seen before. Now, in addition to the capabilities of the Roman Space Telescope, one interesting thing is concerning unraveled galaxies formation physics, like for example understanding the dark matter position of those mysterious objects that have never been caught before. It's going to be amazing to see the ability of this Roman Space Telescope using charged particles to visualize or understand behavior of such matter in space. Now, one thing that we understand about galaxies and galaxy clusters is how bright they are, which of course relates to its mass. But looking at how it is right now with all what we see concerning the web-like structures that is viewed based on a pinhole view from James Webb Telescope and Hubble Space Telescope, Roman can give you a couple of slides of different years or light years or billions of years going back to how it is now to how those galaxies were positioned or created at a couple of years before that and even billions of years before that. And so this can show you some interesting relationship and understanding of how the cosmos evolved from what we have today, which is more of a visual of the web-like, to more of that which wasn't too prominent as you look at slices of billions of years ago of that same image. So it's really fascinating to have that in mind when it comes to understanding the evolution of universe and how that connects to the web-like features. So one example that this article provides is in terms of while astronomers have discovered halos of dark matter enveloping galaxies, we are not sure how they formed. Now, by seeing how gravitational lensing, which we talk about, is when we have a heavy mass and this heavy mass bends space and time when light passes or coming from a particular source that is further beyond that particular heavy mass, that light bends around that heavy object and comes in contact with James Webb Telescope. That is why you're able to see that curve or stretch of galaxies as you're visualizing those images that are produced by James Webb Telescope. And so this is a nice way that you can see beyond a heavy object to further back in time, most likely getting close to the early universe. And so this here, in terms of by seeing how gravitational lensing caused by a dark matter wraps the appearance of further objects, Roman will help us to see how the halos developed over cosmic time. Now, the goal of using the Roman Space Telescope is to be able to scan a large area of the universe, and then by analyzing and finding specific interesting spots, which we call a pinhole finding surveillance, they can now use the other telescopes, Hubble alongside that of Webb's telescope, to be able to understand and zoom in to see more details, which is for using the Webb telescope alongside using the Hubble Space Telescope based on the wavelength that we talked about. Alongside, the goal of these surveillance is that the Roman is going to be producing around 100,000 pictures every year, and that is the goal. That is a lot of data that will be collected, and what are the many segments that maybe we can actually map the whole universe, definitely using the Roman Space Telescope, and then they will be able to use Hubble Space Telescope and alongside James Webb Telescope to find different regions, and maybe they can be able to map things based on going back in slices of time leading to maybe 13.6 billion years ago. So I hope you found this video informative in terms of the abilities of this new telescope that will be launched in May 2027. What are your thoughts about its ability? Do you think there's a future for these in terms of understanding the cosmos evolution, and also how this will shape our understanding of dark matter? All the same, thanks for following me through this. See you on the next one. Stay smart as always and believe in yourselves.